We're going to talk about choosing a Kubernetes runtime today. My name is Justin Cormack. I work at Docker, and I've been working on runtimes for kind of a long time, which is kind of why I decided to do this talk. I'm based in Cambridge. This is a picture of down the road from my house. Cambridge is a sort of science village in England. This is where quasars were discovered 50 years ago. It's very scenic, just full of people doing tech. It's kind of an interesting place if you like tech and countryside. I've been working on container infrastructure and security for many years, and so I kind of got a lot of opinions about runtimes, and I think we're in a kind of really interesting space with runtimes this year in particular, where it's particularly interesting. So let's just start by talking about what we mean by a runtime. Once upon a time, long before Kubernetes actually had been released at all, Docker was the first container runtime, and we actually used LXC, which is this project that's still around, just did a release yesterday or today, as a container runtime, and this was just a way of running containers. Then we made this thing called libcontainer, and then that became the Open Container Initiative, which is a Linux Foundation project that's kind of a sister foundation of the CNCF. And there was this collaborative project called runc, which basically could run Linux containers. And everything was kind of straightforward. Everyone just wanted to use this, run Linux containers. We had one thing. There was a whole community around supporting this one thing, and this was really to stop people kind of going off and forking things, but to work together as a community, and that was all great and wonderful. And this project's still around, still very healthy, and we'll have a 1.0 release almost any day now. But then this year, or just a little bit last year, but mainly this year, everyone suddenly got interested in doing other things with runtimes, and this year in particular has been the year of choice in container runtimes. Last year we had clear containers and Hyper merging to form Kata containers at KubeCon this time last year, and they went on to release their 1.0 release this year. At KubeCon Europe earlier this year, we had Google launched gVisor. We had the whole Windows container runtime being merged into, being standardized as part of the OCI. IBM released a unikernel runtime called Nabla. Systemd started doing OCI containers in a funny sort of way. Google released a container runtime for Chrome OS, so you could run containers on Chrome OS with this custom runtime. Amazon launched Firecracker, which we're going to talk about later, which was just a couple of weeks ago after I'd written the first version of this talk. It was like, I have to change it now. And the OCI standardization process is not just supporting Linux now, but it has the standards for Windows, Solaris, and virtual machines, although the Solaris port is kind of a bit dead. So it's a year of diversity, and so that's why this kind of talks about what does this mean for me? How do I choose? What does it matter to me? Why do I have to make a choice? Why do I want to choose a different runtime? So the original Kubernetes sort of specification, the API justification was what Tim Allclair proposed around, it was just before KubeCon EU, which was called the Sandboxes API, and this was a checkbox you were going to be able to put in your Kubernetes saying, do I want a sandbox or do I not want a sandbox? This proposal was rejected in the end by Signode as not really being entirely flexible enough and just being slightly too opinionated. And it was replaced by this thing called runtime class, which was a generic string without any particular semantics. last time I looked, the CRI was still calling it, we're still using the sandbox untrusted workload flag rather than the string, but it's sort of not really being used very much yet. It's not quite clear what the semantics for the runtime class are going to end up looking like, but actually the original use case of tick box of more isolated or less isolated is actually what most people are kind of interested in. I think that's still a useful way of thinking about it. All the runtimes we're going to talk about today are really, I want more sandboxing. And that's still kind of the more useful way of thinking about it. In principle, there's a class and you can select lots of different things, but we're really going to talk about this idea of untrusted workloads. So what do we mean by untrusted? What is this sort of yes/no tick box? Is my workload untrusted? So untrusted code is basically a slightly vague term, but it really means code that you either haven't written yourself and you are just getting it from someone else who's just giving you some code and you're just going to run it without reading it. So if you've ever downloaded some code from the internet and run it, that's untrusted code, unless you've actually looked at it. If you curl to bash, untrusted code. Or it's code that deals with very hostile inputs. One of the common things is things like media processing, where most programs that do processing of audio or video or image files and things like that have had a lot of vulnerabilities in the past because the input that they're running can be a sort of a hostile input that's designed to attack the program, and typically these programs are not very well tested against hostile input. They will decode correct input, and they will often crash or be exploitable with hostile input. And this is gradually getting better as people do fuzzing, but it's been a traditional case where you need to be a bit careful and not trust your code. And if you're actually a hosting provider providing a service to other people, all code is untrusted. Your customers are there, and they may be running anything, and they may be trying to attack your infrastructure or anything like that. So that's definitely untrusted code. So if you're in that position, that's untrusted code. So these are the kind of cases of which we normally refer to code as untrusted. Code that you write yourself is not untrusted code. If you don't trust your developers to write code, fix that first. Don't treat your developers as hostile. Some people are laughing, but seriously, I work in security. I've had conversations where people literally do treat their developers as hostile people trying to attack their platform. It's not actually that uncommon. Particularly, I think one of the things is that that the whole DevSecOps movement is about helping security people work with developers and ops people, and traditionally, security people have just treated everyone else as being hostile and out to get them, and claim that they don't know what they're doing, that they're running all sorts of stupid things, blah blah blah, and they have had that kind of attitude, and it's really really not helpful. If you want to build a platform that is as secure as AWS, say, because you actually want to run untrusted code, that's a huge investment. We'll talk about that a little bit later, but you don't really want to do that with your internal platforms for your lovely developers who you work with every day and have lunch with. The best thing to do is actually work out what your problems are with their security processes and work out how to work together and improve that. So security testing, code review, and all those things doing, code quality. Security is really about code quality. It's about code quality, particularly in the cases where the code is running in an unexpected path rather than a happy path, which generally is often less tested. But it's really, really important that we're not adding a Kubernetes runtime in order to deal with our developers and problems with our processes. But there are a few cases where treating your internal code as untrusted isn't maybe a good thing. So I talked about media processing, things like that, where it's difficult to get really good code and to totally trust it. So Kubernetes runs on containers, and then the sort of question that people ask is, do containers contain? I mean, they're called containers. They sound like they contain. Does any of this stuff matter? Is my thing secure enough anyway if I just run it in containers? And the first thing is, containers do help contain. Their name does mean something. It's not totally stupid. It's definitely, running stuff in containers is better than not running it in containers from a security point of view. But all code has bugs, and all bugs can be security issues. One of the things about Linux containers in particular, and also Windows process containers, is that they're running in the same kernel, and kernels have bugs, and those kernel bugs can let you escape from a container potentially. If we look at what's actually happened in practice, misconfiguration is actually probably the biggest issue. So if we look at things like the Kubernetes volume CVE that we had earlier this year, that was effectively a kind of misconfiguration issue around volumes. And you can also just misconfigure things yourself quite easily, and those things are kind of things that can let people escape from containers if you mount parts of the host into the container and things like that. In general, mounts are kind of problematic for security reasons often. Kernel bugs that let you escape containers do happen. We have a few of them every year. They are one of the reasons why you should always make sure that you've got an up-to-date host system, you update your kernels on a regular basis. They aren't something that you see in practice people exploiting a lot. I'd say there's normally 4, maybe 5 known exploits a year that you could use to escape from containers. Some of them, the Docker default seccomp policy has blocked in the past, and some of them it hasn't. Some of these bugs are really kind of obscure to exploit. Some of them are things that some of them don't require any privileges at all. We had a kernel exploit recently that only required fork and mmap, so it's totally impossible to block with any kind of policy. And we've had other bugs. There was a bug in runc 2 or 3, maybe I think 2 years ago, that allowed container escape due to issues in runc itself. So overall, containers do contain, but there are bugs. There are bugs in everything, and so the question is it sufficient for my purposes? Can I mitigate these bugs with other defense in depth? I mentioned seccomp, which is not yet the default in Kubernetes, and one day that will switch and be turned on, but you can turn it on yourself. SE Linux and AppArmor have stopped a lot of these bugs from being exploitable in production. I mentioned updates, always update everything. Locking down, minimizing what's on the host, dropping all the capabilities with the pod security policy lets you enforce these things in a kind of not very granular way. Don't run containers as root. Containers running as root have extra privileges. They're slightly easier to exploit. There's usually a few extra kernel interfaces they can use, and if you're not running as root, that kind of minimizes things. And repaving and re-updating things. So even if things get exploited, it takes time for attackers to do that, and if you update your containers on a regular basis, like every day, then it's harder for persistent attacks to last. And if you repave your entire infrastructure because it's all automated in the cloud, then that also really helps. It means that you can rebuild everything with new kernels and new security updates more quickly, but also it just generally helps to stop any persistent attackers. So these are kind of things that you should be thinking about doing anyway, regardless of runtimes. And for most people, in most cases, these mitigations will actually be totally sufficient for all the things you'll actually see in practice. If you look at the actual kind of container exploits we see in practice, a lot of them are just exploiting misconfiguration to do Monero mining and things like that, and they're not really, don't involve much actual sort of container escape or anything. If people just want to run stuff on your infrastructure, they don't need to escape from your containers. They can just run it in your containers. So runtimes, the actual runtime is not necessarily what's the most important thing for doing things in practice. So do the mitigations first, make sure that you have already locked down everything you're running as much as possible before you even think about runtimes. But let's talk about alternative runtimes. So the first real kind of production-ready alternative runtime we saw was Kata containers. As I said, it was a merger of two kind of similar projects, Clear Containers from Intel and Hyper.sh. It basically, instead of running containers as a Linux container, it runs each container as a virtual machine. Virtual machines are kind of well understood isolation technology. They've been around for a long time. So essentially, you boot up a little tiny virtual machine with the smallest Linux kernel you can actually sanely build in it for each container. It uses, by default, uses QEMU running on KVM or QEMU Lite, which is their stripped-down version of QEMU with more of the pieces removed. If you look at the history of security issues in virtualization, QEMU has had a lot of problems. Like there was a security issue with the floppy drive emulation, because if you emulate a computer, a virtual machine, you obviously emulate the floppy drive in the virtual machine because all computers have floppy disks. Actually, that was one case where various people were not actually vulnerable because they had removed the floppy drive anyway, but it was, there were issues like this with QEMU in the past because it was designed really around emulating a whole computer rather than being a lockdown runtime for actually being secure. In order to run Kata containers, you need to not be already running in a VM unless you're actually using nested virtualization, which is kind of complicated. So ideally, you'll run this on bare metal. So that actually rules out, that used to rule out pretty much everyone actually trying it out until AWS actually started releasing bare metal machines this year. Was it this year? Yeah, or late last year. So if you're running on AWS bare metal instances, this can actually run in a sane way. Google and Azure cloud platforms do support nested virtualization to some extent. Azure support it as a proper security boundary, they say. I've got a meeting about that later. I'll talk to them about that. But Google, I'm not sure if they count it as a security boundary, so it's not clear if that's necessarily that secure. And if you're running on-prem, again, you'd have to be running bare metal to run this. So that kind of is a bit of a limiting factor for some people in actually putting this into production. There's also some overhead. Virtual machines take up more memory than containers because the memory is specifically allocated rather than shared. Kata containers is used in production at least Alibaba, JD.com. I believe that DigitalOcean are using it. I think when I talked to them, at least they were using Hyper before. I haven't talked to them recently, so I'm not sure. But yeah, so it's real. It's being used in production by people who, in particular, who are running public cloud type services around providing containers for people to run securely. Hostile people. So it's a real production runtime. It definitely it's definitely working. gVisor, as I said, was launched by Google this year. It's a totally different model. It's based on actually emulating Linux rather than running a little Linux, a separate isolated Linux. So they've actually written a complete emulation of Linux in Go, which every time when your program runs, it does a system call. Instead of doing the actual system call, it gets trapped. It calls into Go runtime, which then basically runs the code to do that system call. This sounds kind of a bizarre and complicated thing to do. I think it's quite, it's actually really interesting code base, and it's something that, and the team are really friendly and helpful if you were interested in how this actually works in practice. So if you're interested in the internals of it, I highly recommend just reading the code and talking to the team who run it. Because it has to emulate the whole of Linux, it's not actually fully complete because Linux is a gigantic interface. It has several hundred system calls, but some of those are just ways of hiding thousands more interfaces that get more and more obscure. But it runs most things. I mean, when they launched it, there was an issue of doesn't run Nginx, which was kind of always the first application I tend to run on things to test them out, but actually they fixed that issue very quickly. And if you report issues on particular applications, they're very good at fixing them because there'll be just one little bit of emulation that's missing. The sandbox is sandboxed. Always like layers of sandboxing. So the emulation code runs as an unprivileged user with capabilities dropped, and it's wrapped in seccomp to stop it doing anything it shouldn't do. It has two backends for how to trap these system calls. One of them is ptrace, which is slow but works anywhere without any particular privileges, and the other is a sort of KVM-based thing. It's not a full virtual machine, but it uses the virtualization features of the CPU to make the traps faster. So it runs with a lot better performance, but again, it requires that you're running on bare metal or something that can actually support the virtualization extensions to the CPU. So it's basically just a bunch of stubs that do the system call trapping and some memory mapping in the virtualization, which is the backend that you should probably use because it's faster and it's got a more understandable security model. So gVisor is used in production on Google App Engine on the kind of the new released version that they did this year. So it's definitely production grade and secure and design, battle tested for their use case. But it's kind of a new, from the open source point of view, it's kind of a new project. So I don't know if anyone outside Google with it in production yet, but maybe there are some people. But it's definitely something that is mature. It wasn't just released now. If you look at the history of the code, it goes back many years, and it's definitely not a sort of an incomplete project. So both those projects are the ones that are production ready. You could put them into production now. Both of them really fundamentally require that you run them on something that supports virtualization ideally. I'm very much not a believer that nested virtualization is a security boundary, but as I said, I've got a meeting with Microsoft later who are going to try and change my mind about Azure, but we'll see. You can run them on AWS bare metal, on-prem bare metal providers like Packet.net, and other people like that who give you bare metal machines. The security boundaries that virtualization gives you are kind of useful, and if you just use those in order to just run a virtual machine, in order to run containers on the virtual machine, it's kind of pointless running containers inside a virtual machine if you don't have to. it's better to run containers on bare metal and then use the virtualization bits if you need to isolate containers more securely, I think. And I think we'll see more people kind of moving towards this model. It was really useful that AWS started releasing bare metal machines because that made it much more available to people who want to try things out. Yeah, using virtual machines just as a platform substrate for ease of management kind of means that you can't then use them to do useful things like runtime security instead. So I think people should think about shifting to running containers on bare metal platforms in order to make more use of the bits of virtualization support in hardware that are there. Another runtime that came out this year that was Nabla, which was a unikernel runtime. It's quite different from the other ones in that you have to rewrite your application as a unikernel. So basically, you can't just take an unmodified Linux application and run it. So that's much, much less accessible to the average user than the two we've talked about before. But it has nice security properties. It kind of looks like a sort of hybrid of the kind of gVisor model in a way. I mean, with gVisor, so they emulate the Linux kernel, so they have a TCP stack written in Go that they run. If you're running a unikernel, you also link your application to your own TCP stack and run that yourself. So you could use the same TCP stack that they're using, for example, but you have to do that work yourself. So it's definitely a more complicated thing. There is a talk about this later, I think. How secure are these runtimes once you've done that? You're still running an infrastructure that runs on Linux, even if you're running a hypervisor with you're running Kata containers, you're running your containers in a virtual machine. You're still underlying that. You're still using Linux as the underlying hypervisor, running KVM. It's still actually, when you call out to the hypervisor to do things, you're still calling into Linux code. There are still bugs in Linux code. The virtualization boundary is kind of secure, but actually you kind of have to basically still call into the system to actually get things done, to talk to the network and things like that. So there are still potential exploits in all these things. And we had all these issues around things like Spectre and Meltdown late last year, early this year, which allowed you to do things like read memory from the inside the hypervisor and things like that. So and there's been a whole series of side channel attacks into virtual machines and other processes and things this year. So you shouldn't assume that just because you're using a VM to run your containers or container runtime that you're totally secure. Security is just a difficult thing. There are more and more attacks on everything. Running untrusted code in production is a really, really hard problem. As I said before, if you don't have to do it, don't do it. If you're not providing a public cloud API, then your life's much easier. You can buy more, if you want to isolate your code and you're really, really paranoid about it, you can buy more computers. I highly recommend buying more computers. Computers are kind of cheap. You can get lots of them. You don't have to, if you're running an application that's you're totally and utterly paranoid about the data that's in it or the security of that application, you can still put it on its own computer. You can still manage that with Kubernetes, as a single node that just runs that application, or some replicas of that application or something if you want. But you don't have to, only think about isolation in terms of runtimes and things like that. Just think about it in terms of, which computer is this running on? Does it matter? What else is running on the same computer? What else could attack it on the same computer? And it's kind of important that if you have some highly sensitive applications and some less sensitive applications, it's a good idea to just run them on different computers. So for example, build and CI should not run on your PCI compliant infrastructure on the same machine. There's no reason to do this. Actually isolating things by importance is a really helpful way of thinking about security as well. There are a bunch of talks on the details of some of these things, by the way. If you want to kind of go into Kata and Nabla and gVisor, there's 2 talks later on today, which I highly recommend you go to if you want to really dig into those details. There's a bunch of stuff on the actual detailed security issues and exactly what the attack surfaces are and those kinds of things. So definitely go to those talks if you're interested. These are not the only runtimes. There's actually, that's the great thing, there's loads and loads of runtimes, and so I want to talk about some more choices you've got. We talked about runc, but there's actually a whole bunch of kind of early re-implementations of runc, which are kind of interesting. Oracle started rewriting runc in Rust. Rewriting things in Rust is a great thing to do. I don't know how much. I haven't actually looked at how much of it is now completed. When they announced that it was kind of fairly early and experimental, I'm not sure if they're using it in production. If anyone from Oracle, please let me know. Chrome OS launched a container runtime this year, and they wrote an alternative to runc in C++. It's fairly complete. It has a few customizations for the Chrome OS platform and a few things missing, but it's kind of actually quite a nice runtime. Systemd, I mentioned before, Systemd Nspawn got some OCI runtime support, which I haven't looked at. It seems a bizarre idea, but I just included it for completeness. I think, because I don't think it ships with it by default. I think it's a pluggable thing. But yeah, so there's people just looking at the actual Linux OCI runtime and experimenting with new implementations. Firecracker was probably the most talked about announcement from AWS reInvent a couple of weeks ago. So Firecracker is basically an implementation of the KVM runtime, but not using QEMU. We talked about the security issues that QEMU's had before, and but there hasn't really been very many alternatives to using QEMU that have been open and production ready or anything before. But I think it was early this year or late last year I think early this year, when Chrome OS was doing containers, they also added a VM runtime called CrossVM, which was written in Rust, nice security isolation with seccomp, and Amazon basically took that code base and specialized it even more for their use case rather than the Chrome OS use case of basically running Lambda. So AWS Lambda now runs inside Firecracker, and it's the whole architecture of the thing was designed around being minimal, being secure, written in Rust with all the I/O pieces sandboxed with seccomp, as few device drivers as possible. It's basically got just a virtual network device, a virtual block device, and that's about it. And a keyboard that's got one button on which resets the machine. CrossVM had a few extra drivers on that as well, because CrossVM could actually do graphics support and things like that. So Amazon stripped those out and did a bunch of rewrite work on that. And when Firecracker was announced, they also announced that they're doing a containerd integration in order to so you can use it as a container runtime. That's very early still. It's kind of, so they've only been working on it kind of briefly, but basically it plugs into containerd, replacing as a sort of shim layer plugin on containerd rather than a runc plugin. But once that's ready, that means that should just automatically work if you use the containerd CRI implementation for Kubernetes, or if you probably should work if you're running Docker on Kubernetes as well, I guess. But it's kind of that implementation is still very early. It's not production ready yet, but hopefully will be soon. Kata containers are also looking at plugging Firecracker in instead of QEMU. So that will be another way in which, so you, at least that's what I heard yesterday. So I believe that you will be able to run it as a Kata containers driver instead of QEMU. They used to not use KVM back in the day as well. So, Clear Containers used not to use KVM and QEMU, and it's definitely improves the security model of running virtualization if you run a really, really locked down virtual machine manager. So Firecracker is really kind of exciting. It's, part of the, if you really care enough about security to run things in a virtual machine, you should run them with a virtual machine manager that's also built for security, not one that was built to do PC emulation as a kind of hack back in the 90s, and got incorporated into KVM kind of by mistake in a way because there was nothing else available. This tweet was very funny, and I laughed at it a lot for a long time, so I put it in my talk. Why is Firecracker called Firecracker? Because people will try to use it to implement Lambda themselves and blow their hands off in the process. You probably don't want to spend your time re-implementing Lambda necessarily, I think, but the use case as a secure runtime for Kubernetes is actually kind of interesting, and because it's very lightweight and small and fast, it should be not significantly different in performance from running native containers. So it should be an interesting thing to just plug in and use from that point of view. But if you want to implement your own Lambda, there's also a couple of other things you need to do as well as just having a runtime, a VMM for it. Other runtimes on other operating systems is something that kind of took off a lot this year. So Windows containers have been around for quite a while, but the implementation for them was kind of originally built in directly into Docker. And now there's a proper standalone runtime, runHCS, which is runc compatible as a part of the OCI spec for Windows, and that stuff is all kind of become much more standardized this year. Windows actually has two kinds of isolation. It basically has process isolation and virtual machine isolation in the same way as normal containers and, say, Kata containers, but they're already built into the runtime. And you just, with Docker, you can just use minus isolation equals Hyper-V or equals process, and they just kind of work like that. So they kind of already have some of these options that the Linux runtimes are kind of adding. So you get a choice of security boundaries and those things already. So if you're using Windows containers, you can already kind of play with some of the things that are more experimental in Linux containers. There was a Solaris runtime, but they didn't appear to work on it this year. So I think it's kind of dead, which is kind of... but Oracle have certainly shipped one in the past. FreeBSD had a runtime, and actually, I said some interested in reviving, but nothing concrete, but someone pointed me at a Git repo the other day, so I believe that's no longer true, and there actually is a FreeBSD runc compatible runtime being worked on. I kind of hear things about other macOS. I kind of did some work on that at one point, and someone else is doing some work on it. Maybe that'll happen. I even heard some rumors about OpenBSD, nothing concrete yet. But so containers are not just Linux containers, and there are definitely other runtimes being worked on that are compatible and plug into the same infrastructure. You can run with Containerd or Docker, and if you want to write runtime, it's kind of fun. Read the spec, understand the platform. So in summary, deprivilege your applications first before you even think about doing any of this stuff. You know, if you look at things like Lambda, they do not run as root. They run unprivileged inside a VM. You know, multiple layers of capabilities. If you really, really, really want to run untrusted code, it's a huge, difficult thing. Build a security team first, and eternal vigilance is really, really important. There's a lot that can go wrong, and so on. If you just want extra security, harden everything first, do intrusion detection. Once you've got to there, then you can think about these new runtimes. Thanks very much.